The natural frequency is the frequency at which an object most easily vibrates or oscillates. All things have a natural frequency. If you push a swing, it oscillates back and forth at a certain natural frequency according to its length. If you pluck a harp string, it oscillates back and forth at a certain natural frequency depending on its length and perhaps its thickness. A forced vibration occurs when we apply a force to something. Apply a force, it vibrates. Apply a force, it vibrates. Apply a force, it vibrates. Resonance is what happens when a force is repeatedly applied to an object at the object's natural frequency. If a child is in a swing and you push the swing, you wait. There is a certain time before you push it again. You don't just put the child in the swing and go push, 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 push. No, you push and he swings back, and you push and the child swings back, and you push. In other words, there's a certain timing that you apply your force. And if you apply that force at the same frequency as the natural frequency of that swing, you're going to get very large amplitude. Some examples of resonance. We've already talked about a swing. You may have seen a demonstration of a singer shattering a crystal wine glass with the voice. There's a certain frequency at which that wine glass structure wants to oscillate, and if a sound wave with that exact frequency is applied to that system, that structure can be made to go through a very large amplitude, enough so that it can shatter the wine glass. You may have also seen footage of the Tacoma Narrows Bridge in Washington State in 1940. That bridge had a certain frequency at which it naturally wanted to oscillate. Well, it turned out that the rate at which the wind would, in a sense, bump into the bridge and then be shed, vortex shedding I believe it's called, the frequency at which those little forces were applied to the bridge happened to coincide with the natural frequency of the bridge, and it came down. I've heard a story that a British regiment in 1831 was walking across a footbridge, and they were all marching in step, as regiments tend to do, and it so happened that the step frequency was just exactly the natural frequency of that little footbridge, and it caused the bridge to collapse, which apparently is why regiments break step if they're crossing small bridges, so that that sort of thing doesn't happen anymore. If you've ever heard power lines humming in the wind, those are given a name. They're called aeolian harps. It's the same idea. When the wind brushes against the wire, as it bounces off, it gives the wire a little push, and if those little pushes occur at the natural frequency of those wires, then those wires can get a large amplitude and will hum. Another example of an aeolian harp is from the song The Wreck of the Edmund Fitzgerald, where this lyric is included. The wind in the wires made a tattletale sound as a wave broke over the railing. That's an aeolian harp. That's an example of resonance. An object's natural frequency is the frequency at which it wants to oscillate. An object experiences a forced vibration when an applied force disturbs its equilibrium. The object undergoes an oscillation in response. Resonance occurs when the frequency of a continually applied force matches an object's natural frequency. The result is a large and potentially dangerous amplitude.